This video is going to focus on percentages of percents. So many percents, but we want to sort of make it less confusing. The reality when we look at absolute and relative change is we're still using the same formulas we've been using this whole lesson. The difference is the numbers we're dealing with are percentages. So it helps us sort of differentiate between what are we finding when we talk about absolute change versus when we talk about the relative change. And so when we do absolute change, we talk about something increasing by a percentage point. So it's like how many percent points got added to the original reference value. So the label would actually be percentage points versus when we look at relative change is still a percent change. So it's the percent increase versus the percentage points, think added. So it's like an adding relationship versus a multiplicative relationship. So we're going to look at an example here. And we have sort of two sets of data, and we're going to compare them sort of two different ways, find some absolute and relative differences with them. And so we have from 2011 to 2016, current cigarette smoking declined among middle and high school students. Woohoo! About 2 of every 100 middle school students, or 2.2%, reported in 2016 that they smoked cigarettes in the past 30 days. That's a decrease from 4.3% in 2011. Then, unfortunately, we have the advent of electronic cigarettes, and that in 2016 is now at 4.3%, and it used to only be 0.6%. So we have lots of numbers here that we can compare. And so we're going to start by comparing cigarette smoking to e-cigarettes. And for the sake of this problem, we're going to take the numbers from 2016 and sort of compare them. Now notice, you might be going, okay, well, what's my reference point? What's the original value here? They're both the same year. None of them are the national average. But it's saying we're comparing cigarettes to e-cigarettes. So when we deal with problems like that, we're going to assume that the number you are comparing it to, that's now going to be our sort of reference point. That's what we're comparing it to. So if I want to then find the absolute change, that's going to be my cigarette smoking number. So that 2.2% minus my e-cigarette reference percent all over, I'm doing relative, not absolute. There is no all over. It's just 2.2 minus 4.3. And if I subtract that out, I would have negative 2.1 percentage points. And what does that tell me? Is that cigarette smoking was about 2.1 percentage points less than e-cigarettes for this demographic. Okay, but now I want to do it as a relative change. So I'm going to take that absolute change, that negative, so relative change. So I'm going to take my absolute change of 2.1 and I'm going to divide it by that 4.3. And I would get negative 0.488 or 48.8% decrease. Or less, I could say. Decrease is probably the wrong word. Let's say less than. So the cigarette smoking was 48.8% less than e-cigarette smoking. So that's sort of looking at absolute change versus relative change. So let's do the same thing. We're going to use the cigarette smoking values But this time we're going to do a year comparison, just to sort of practice looking at percents and thinking about what are we finding. So I'm going to change my colors really quick just so we don't bleed into columns. So if I want to do the absolute change here, that would be new minus old. So the 2.2 minus my original value would be negative 2.1. And so it happened to be the exact same absolute change as our previous problem. And so there was a decrease of 2.1 percentage points between 2011 and 2016 for junior high and high school smokers. Okay, let's make our relative change. So we'd have that negative 2.1 divided by 4.3. And we're going to get the exact same value, negative 0.488. Isn't it funny how data worked out this way? And that was a 48.8% decrease in sort of smoking from 2011 to 2016. Do we have enough information to make conclusions about the number of middle school students that were smoking? No. And this is a really important idea to keep in mind with percents. We don't actually know the number of students who are represented. We're just given about 2 out of every 100. But how many are out there? We don't know. And so we need to be very careful when we're using percents to generalize actual values within problems. Percents, we don't know the size of the population. And so we don't want to make conclusions that we don't know. Similar with this, I'm not going to spend a lot of time talking about it, but I briefly want to touch on the fact that when we can't average percents for the same reason that we couldn't make conclusions about the population. If I have 40% of something, so 40%, people who like to cook, and 60% of people who like to run, they average together to make 50%. But I don't actually know 40% of what, like what population am I looking at? So we don't average percents because we don't know how many that percent is out of. And that changes what the average or the percent would be depending on the sort of total population size. So when it comes to averaging percents, just don't do it.